Hi all, in this module, we'll learn about the first chapter of physics of ninth class, that is motion. So before going into this chapter motion, let us watch a small video.
Mom, the car is moving. Birds are flying. We are walking. Are all these same?
Yes, son, these are all same. This is called as motion. The ball with which you play, when on the slope, rolls down, right? It is also motion. The planets in our solar system are also in motion. Therefore, it is very important to learn about this term motion. In this module, you will learn various things about motion.
Mom, the car is moving.
So in this chapter, we'll mainly focus on all these topics. That is, first we'll look in detail about what is motion. Then we'll move on to different types of motion, that is uniform motion and non-uniform motion. Then we'll discuss in detail about displacement, distance, speed, velocity as well as acceleration. Then we'll discuss about the graphical representation of motion, that is distance time graph as well as velocity time graph. Then we'll derive the equations of motion using the graphical method, that is for equation for velocity time relation as well as for position time relation and position velocity relation. So first let us move on to the first topic, that is motion. So what is motion? We can say that an object is said to be in motion if it changes its position with respect to time or with respect to a reference. So if an object, when seen in the first second, was here, and in the next second, if the object moves to here, that is with respect to time, the object has changed its position. Then we can say that the object is in motion. Then what about if it does not change its position? If an object is remaining at the same position even after a few couple of time, then we can say that the object is at rest. So an object is said to be in motion if it changes its position with respect to time and a point of reference, and an object is said to be at rest if it remains at the same place, that is if it does not changes its position with respect to time. And in order to describe the position, or in order to describe the motion of an object, we have to use something called, we need a reference point. We'll call it as an origin. With respect to the origin, the position of our object is this one. So in the next slide, you will have a clear idea about what is this origin. So here you can see that the ball is moving from one position to the other. The ball was here on the right side of this reference point. That is the origin. And in the next second, the ball is moving to the left side. In this picture, you can see in the first, the ball was here, and in the second, the ball is here. So we can say that with respect to this origin, the ball has moved and it has reached some other position within this time. So this is a motion. The ball is moving from one place to another. Its position is changed from the left to the right side of this bottle. So that is the motion. So here this bottle is the origin, and with respect to this bottle, the ball is moving. Oh. Then it also depends on the frame of reference. That is, the motion depends on the frame of reference. So what is this frame of reference? Frame of reference can be defined as it is an arbitrary thing. That is, it's not a concrete thing. It is not something that is directly visible. It is an arbitrary thing, that is a mental idea. So it is an arbitrary set of axes with reference to which the position of an object is described. And it is a frame of reference can be an object. It can be a person like me and like you, or it can be a scenario. So that, for example, with respect to me, the something is in motion. That subject will not be in motion with respect to your frame of reference. So frame of reference is an arbitrary set of axes with reference to which the position of an object is described. So you can see in this example, for the passengers sitting inside this train, the co-passengers are in rest. All are sitting safely inside the train. They are not moving. They are at rest. And the things that is outside the train for them is moving backward. That is their frame of reference. So the co-passengers are at rest and the things outside is moving backward. But what about the people standing on outside the train? Yes, for them, the train along with the passengers are moving. So that is two frames of reference. Hope the topic is clear. Now we'll move on to our that is types of motion. So this motion can be mainly classified based on two criteria. First one is based on the nature of the motion with respect to time, and second one based on the path traveled by the object. So based on the nature of the motion with respect to time, we can mainly classify it into two. First one is uniform motion and the next is non-uniform motion. So what is this uniform motion? When an object travels equal distance in equal interval of time, we can say that the object is in uniform motion. For example, take the case of a car which is being driven in a straight road. If the car travels 100 meter in 1 second and in the next second it again travel 100 meter, in the third second it again travel 100 meter. So we can see that in the fixed interval of time the car is moving equal distance. That means the car is in uniform motion. The example is the earth revolving around the sun in the solar system. So we know that the earth is revolving around the sun in our solar system. Within a fixed interval of time, the earth is revolving or the earth is traveling equal distance. So the movement of the earth is a uniform motion. Then what is non-uniform motion? An object is said to be in non-uniform motion if it travels unequal distance in equal interval of time. If we take the example of the same car, for example, in the first second, the car moved a 10, not 10, 100 meter. And in the next second, the car moves only 50 meter. In the third second, the car moved 150 meter. So is that a uniform motion? No. The car is moving unequal distance in equal interval of time. Therefore, it is not uniform motion. And such type of motion are called non-uniform motion. Example, you can see a vehicle which is stuck in a heavy traffic jam. The vehicle can only be driven in a slow range, right? So it may be sometimes it will be equal, sometimes it will be very less. So that is uniform and non-uniform motion. We can make it more clear through a video.
In this video, you can see that the car moves equal distance of 10 m in each second. That is, in 1 second the car moves 10 meter and, in the next second, the car moves 10 more meters, that is 2 seconds the car moved 20 meter, and when the time reached 3 seconds the car moves 30 m. That is, the car moves equal distance in equal interval of time. This type of motion is called uniform motion.
But here you can see that, in the first second the car moves 10 meter. And in the next second it travels 20 more meters and reaches 30 meter. And on the third minute it travels 10 meter more and reaches 40 meter. This shows that the car moves unequally in equal intervals. This motion is called non-uniform motion.
Hope through the video, uniform and non-uniform motion are clear. So next we'll discuss about the types of motion based on the path taken by the object. So it can be mainly classified into four. First one is rectilinear motion. So what is rectilinear motion? It can also be called as a straight line motion. So an object is said to be in rectilinear motion if it travels in a straight line. So you can see in this photo that this car is moving along a straight road. We can think about this as a road. So this car is moving along a straight line. So we can say that the car is in a rectilinear motion. Then what is circular motion? Circular motion, if the object is traveling around the circumference of a circle, we can say that it is a circular motion. So you can see here the planets. Planets are revolving in the orbits, that is along the circumference of a circle. So hence we can say that the motion of the planets is a circular motion. Then comes our rotatory motion. Here the object is rotating around a central axis. It forms a concentric circle around the axis of motion. Such motion is called as rotatory motion. An example we can talk is the motion of a vehicle tire. You can see this is the central axis for this tire, and the other part will rotate around this central axis. So that is rotatory motion. The last one is vibrational or periodic motion. So here the particle or the object moves back and forth. It vibrates. It moves back and forth periodically around a fixed point. Example you can see is a clock pendulum or any type of pendulum. So this is the fixed point, and from here this pendulum moves to this side, come back to this position, then moves to this side, again come back to this position. So that is vibrational and periodic motion. Hope the classification of motion based on two criteria are clear. So based on the nature of motion with respect to time, we classified them into uniform motion and non-uniform motion. And based on the path taken by the object, we classified them into four: rectilinear motion, rotatory motion, circular motion, as well as vibrational or periodic motion. So, in order to describe the motion of an object, we will have to use some physical quantities. So, what are these physical quantities? Here, we will use distance and displacement to describe the motion of an object. And we will learn in detail about distance and displacement in our next slides. So, what is distance? Distance can be defined as the total path traveled by an object. That is what distance is. For example, if you're going from the home to school, if you're going from home to school, the total path traveled by you will be the total distance covered by you. So that is distance. And this distance, it depends on the magnitude. It depends on the magnitude of the path taken. It is not on the direction. Distance, we always used to say like, I have traveled 50 kilometers. I had traveled 100 kilometers from my home to reach the school. So that is distance. And distance is a scalar quantity. So what is distance? It is the total path traveled by an object. So here you can see this is a number line. So imagine that a person who was standing in the position O, he moves to the position B. He travels from 0, maybe in a rectilinear motion, straight line motion, and he reaches a position B. And from there, he is coming back to C. That means first he traveled. That means first he traveled a distance of 35. Then from there, he comes back to this 25. So we can say that he traveled from 0 to 35. That is 35 kilometer he travels. He travels 35 kilometer. Then he comes back from 35 to 25. That means 35 minus 25. We will have, yes, 10 kilometer. So 35 plus 10, the total the student had covered 45 kilometer. So first the person was at this position 0. Then he traveled along this straight line and he reached this position 35. That is, he covered 35 kilometer. Then from B, he is going back to C. That is, from 35 to 25. Then 10 kilometer. He traveled again. So 35 plus 10 kilometer will give you 45 kilometer. So what is the total distance covered by the person? It is 45 kilometer. Hope this concept of distance is clear. Then we'll move on to displacement. So what is displacement? Displacement can be defined as the shortest distance that is traveled by the object from one position to the other. For example, you're going from your home to the school. You have different ways. Either you can go directly from home to school, or else you can travel around the town and then reach to the school. So which is the shortest distance? The shortest distance is the direct one. So that is our displacement. And the other one is our distance. So displacement is the shortest distance traveled by the object from one position to another. And displacement is a vector quantity. We look after the direction as well. And it depends on the initial and final position of the object. So displacement, it depends on the initial and final position of the object. With the same number line, we can describe displacement as well. How? Let us check. So the object is in the position 0 or O position. Then it is moving towards B. Then it is moving towards B and it reached this position 35. So this is 35 kilometer. Then from here it is moving back towards C. That is, it traveled 10 kilometer. So we know that the distance is 35 plus 10, that is 40. But what about displacement? We said that in displacement, the initial and final position of the object is considered. So what is the initial position? Initial position is at 0. And finally, after traveling all over this way, it has reached to a point C, that is 25. So which is the shortest distance to travel from 0 to C or O to C or 0 to 25? The shortest distance is like this, right? Rather than going in this way, the shortest distance is from like this. So our displacement is 25 kilometer. Hope the concept of displacement is clear. Now I have a question for you. An object has moved through a distance. Will it have zero displacement? Just think. Yes, it will have zero displacement. Let us check into this photo. There is a student just like you. He is walking along a circular path and he have reached his original position. So he have covered a distance. Maybe just take example as 0.5 kilometer. The child has covered a 0.5 kilometer along the circular path and he reached the same position. So he'll have a distance of 0.5 kilometer. And what about displacement? The child started his movement from this position and he ended at the same position. So final minus initial. The displacement will be 0. So displacement can be a positive value, can be a negative value, as well as it can be 0. Whether distance can be 0? No. If distance is 0, we can say that the object is in rest. So distance cannot be 0, but displacement can be 0. It is a very important question. Can displacement be 0? You can explain with the help of a circular path. Hope this question is clear. Now you can see here in this video, these are two houses. The first one is here and the second one is here. So the displacement is the shortest distance. Distance you can go from this house to this house through different ways. From here to here you can go through in this way. Like this you can go. Or if you want you can go in this manner as well. And directly also you can go. So displacement will be the shortest distance traveled by the object from to reach from one position to other, and distance will be the total path traveled by the object. Hope that is clear. Now an important question in this part is the difference between distance and displacement. The first major difference is that distance is the total length traveled by the object, or total path covered by the object is distance. What is displacement? It is the shortest distance traveled by the object. Then distance can never be negative as well as 0. If distance is 0, the object is at rest. And it can never be negative. How can we say that? Oh, I travel this much negative distance. We cannot say that, right? So distance can never be negative. But displacement can be negative. When if you start from here and if you walked all this way and if we reached back to the same position, your displacement will be 0. So displacement can be positive, negative as well as 0. Then we said distance is a scalar quantity. We are checking the magnitude. But displacement is a vector quantity. We are checking direction as well as magnitude. Then the distance depends on the path taken by the object. If I am traveling from here to here in this way, this is my distance. If I am traveling in this way, this is my distance. So it depends on the path taken by the object. But displacement, it depends on the initial and final position. My initial position is here and my final position is here. So displacement depends only on this position and the shortest distance that can be traveled from reaching to one position from the other position. So it depends on the initial and final position of the object. Then distance can be greater than or equal to the displacement magnitude. Distance will always be greater than or equal to displacement, whereas displacement will always be less than or equal to the distance covered. That is, from here to here, this is a distance and this is the displacement. You can see that the displacement is lesser than the distance. Or if there is only one way to reach from here to here, both displacement and distance will be the same thing. So distance will always be greater than displacement, whereas displacement will always be lesser, or it will be equal to displacement. Hope the differences are clear. It's a very important question. So, can we move on to an important problem from this session? The problem is, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So, consider this as a square field of side 10 meter. That is, square means it will have all the sides same, right? So let us name this square as A, B, C, and finally D. So this is a square A, B, C, D. And a farmer who was standing at this position A, he travels all these sides of the square and he in 40 seconds and he reaches back to his original position A. And the questions that we have to do is, what will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So first, what is given? For us, it is given that the time is 40 seconds and the farmer travels along the boundary of the square in that 40 seconds. So along the boundary means, yes, it is perimeter. So perimeter of a square is 4 into the side. So 4 into 10 meter. That will give you 40 meter. So perimeter of the square is 40 meter. And the farmer travels the perimeter of the square 40 meter in 40 seconds. Hope it is clear. Then what is to find? We have to find the displacement traveled by the farmer at the end of 2 minutes 20 seconds. So here it is given 2 minutes 20 seconds. But what is the SI unit of time? It is second. So we have to convert this minute into second. How to convert? Here we have 1 minute is equal to 60 seconds. So here we have 2 minutes. So it will be 2 into 60. So 2 into 60 plus we have a 20 second. It is 20 seconds. Sorry for the mistake. Here it is 20 second. So 2 into 60 plus a 20 second. That is, it will give you 120 plus 20, 140 second. So that is the time. We have to find the displacement traveled by the farmer at the end of 140 seconds. So how to find? In 40 seconds, the farmer travels 40 meters. So in 140 seconds, the farmer will cover this square of 40 meters. So what we'll do? We will divide the given time with the given distance or given path. That is the perimeter of a square. So time divided by the path. So in 140 seconds, how many times the farmer can travel around this path? That is found by using time divided by the path. So 140 divided by 40 will give you 3.5. So it will give you 3.5 rounds. Okay. So the farmer is starting from here and the farmer starts from here and he travels around and he reaches here. One round is completed. Then second round, he is traveling and he reaches back to his position. 2 round. Then 3 round plus a half, right? So third round, the farmer is traveling and he reaches here. Now third round is over. Next is a half round. That is, if the farmer is starting from here, he travels along this way and he only reached till half. That is, till C he reached. Then he stopped. That means 3.5. So what is the question? Our question is to find the displacement. And what is displacement? It is the shortest distance traveled by the object. So the farmer was here first and finally he reached here. So what is the shortest distance traveled? Yes, that is AC. So the shortest distance travel will be AC. So in order to find the magnitude of displacement, we have to find the diagonal AC. So how to find the diagonal AC? We have already learned Pythagoras theorem. Right. So what is Pythagoras theorem? Hypotenuse square is equal to base square plus altitude square. So in this figure, it will be AC square is equal to CD square plus AD square. AC square is equal to altitude square AD square plus base square CD square. So what is AD? AD is 10. Why? Because it is a square block. So 10 square plus CD is also 10. 10 square. It will give you AC square. But what we need is AC only. So we have to take the root of that. That is 10 square plus 10 square, the whole root, and we'll get the answer as 14.142, that is 100 square, 100 plus 100. 100 plus 100, sorry, 100 plus 100 and इसका root. So it will give you root 200. Right, 200, which is equal to 14.142 meter. Hope this problem is clear. So it is one of the important problems of this portion.